The broadcast is now starting. All attendees are in listen-only mode.
Hello, good morning, everybody. I think we're just waiting for a few more people just to log in. It's bang on 10 o'clock, so we'd maybe just wait another couple of seconds or so just to make sure everyone can log in if there's any technical issues. Right, okay, let's get started. There's a few more people logging in as we speak, but let's get started. So welcome, everybody. Thank you for taking the time out of your day, your busy day, to join us this morning. My name is Simon Brand. I'm the manufacturing sales manager here, and I'm joined by my colleague Chris England, who's our application engineer, who's going to be taking you through the technical aspects this morning. So any of you that joined us perhaps on our virtual summit in October last year will know that we spent the whole day looking at various different topics throughout the day. And one of those topics was around mass customization and what that meant to you as businesses. And it's the one topic that we've had the most questions about and the most feedback from. So we wanted to take the time today to do a bit more of a deeper dive into really what Ilogic can do for you and how easy it is to get started. So thank you for spending the time with us today. I really hope it's going to be a worthwhile session for you. So let me introduce myself. So I'm Simon Brand. I'm the manufacturing sales manager here at Man & Machine, and I've been in the industry for far too long, and I've been involved in multiple automation projects using Ilogic. It's the topic that gets me even more excited than normal. Yeah, anything that can make you do things quicker, more efficient, and with less human error is a win-win as far as I'm concerned. But let me just take the time for any of you on the call that don't already know us and know Man & Machine. So we are the UK arm, well, yeah, I guess post-Brexit, we are the UK arm of Muncher Maschine Group, who are the largest Autodesk Platinum reseller in Europe. In the UK specifically, we found a bit of a niche in recent years where we've really taken the idea of automation to the next level. And I've got a couple of customer examples I want to just share with you, and then Chris is going to take you through the specifics of how you can get started with Ilogic. So a couple of introduction as to what the elements of what we do here at Man & Machine. So we see ourselves as experts, as specialists in these 7 key areas. Obviously, today's topic is all around automation and how you can automate your design to manufacturing processes. But there are multiple arms of what we do and what we offer as a business. And if any of these areas are interesting to you, please, get in contact. I'm sure a lot of you already do, but these are the kind of topics of conversation that we like to have with our customers. So our software portfolio is mainly, obviously we're the largest Autodesk reseller, so it's predominantly based around Autodesk, but Autodesk is not all that we do. We actually have our own software development arm. So we develop our own software applications, mainly around machining, around CAM, Hypermill, or electrical design, or even Custom X, which is our own automation product. We've also teamed up with a number of other software vendors, software applications, to really complement our own and Autodesk offering, to really offer a complete solution, so that we have all the relevant accreditations and can really offer a complete solution. The one that I will mention on this call is the product there, Cool Orange. For those of you that don't know, Cool Orange is an application that bolts on, if you like, to Autodesk Vault and allows you to trigger certain events, for example, automatic PDF creation or automatic DXF or DWG creation or integration with your ERP system. But the one that's interesting today for us is, and I've got a great customer example in a moment, is the ability to use Cool Orange to automatically trigger automation using Ilogic. And that's really key to one of our customers that I'll show you in a second. Ultimately, here at Man & Machine, our goal is the same. It's always what we want to do is to help you, our customers, to do three things: create better products, whether that's a machine or a component or even a building, to help you sell more of these products. And ultimately, the goal for all of us is to ensure that the businesses that we work for remain profitable. And I think that's the area that we're most of interest for today's topic. How can you become more profitable than you are today? And what's driving that? Well, it's all of us. There's estimated that in the next 30 years, there's going to be 10 billion people on this planet. And that's 10 billion people that all need new, phones and bridges and hospitals and schools and everything that you need. It's estimated actually that a few years ago, there were almost 400,000 new products brought to market in a single year. So it's more competition, more stuff, more people. But at the same time, and specifically in the UK, we see shortages. And a lot of our customers talk to us about the shortages that they see. Yes, in materials, but also shortages. One of the key drivers for a lot of businesses that I speak to is around shortages of finding skilled labor. It's estimated that about 40% of manufacturing businesses in the UK cite not being able to find a skilled workforce as one of their top challenges for the next 3 to 5 years. So whilst the pinnacle is to help you, design better products, sell more products and make more profit, actually we know that a lot of you are under increasing pressure with increased demands and perhaps less resource, and you're under pressure to do more quicker with potentially less people. And it's a challenge. And I guess that's one of the reasons why so many people are logged into this webinar today. But if we take a step back for a moment, if we think about the traditional manufacturing workflow of how manufacturing works, we come up with a concept, we design and redefine that product and make it and sell it and operate it. And ultimately, our profit as a business, the amount we sell it for, less the cost it takes to design it, make it, and operate it, that's our profit margin. Of course, over time, what happens is, with increased competition and increased material costs, our profit margins often get squeezed, and it's a real challenge to stay profitable. There is a number of customers that have bucked that trend in recent years, and the common thread are any customers that embrace and really push the boundaries of one of these 5 key areas, whether it's efficient communication of product design, whether that's visualization or VR, whether it's flexible manufacturing or additive technologies, or even putting sensors in your products with connected services. Anyone that embraces one or more of these key areas can really buck the trend, potentially making more profits for their business. Now, obviously, we're talking today around the first one, personalization and customization. I apologize, this is Autodesk slide, so there's a couple of Z's in the personalized there, but the concept is still the same. Now, any of you that joined us on our virtual summit that I mentioned before and attended the session around what does mass customization mean to you, know that we asked at the start a quick poll. We asked the attendees to answer a question as to what mass customization actually meant for their business. And the results I thought I'd share with you today are pretty interesting, because a lot of people sort of initially thought that mass customization means an online configurator. Some people thought control of salespeople and internal automation. But I thought it was quite interesting because for me, design automation actually means all of these 4 things and more. But it was quite interesting to see the results that we had from the virtual summit back in October. So not that long ago, the idea of manufacturing businesses personalizing or customizing a product for an individual customer requirement was pretty much frowned upon. not because it wasn't possible, but mainly because of the increase in cost, time, and of course resource, so overheads, that personalizing a product meant. So what most customers done, and I'm sure that some on this call can relate to this, what most of you do is you opt for the sort of the standards approach. You know, you take the select number of product variations that fits the majority of customers. Of course, you never know what percentage of customers that fits, but it depends on your product. You may have satisfied 50, 60, 70% of your customers, but there's always that one important customer that wants something slightly different, something a little bit unusual. That's the challenge. Of course, we all think about the car configurator, the idea of customers being able to personalize their product. We've all been on the car configurator websites and spec'd up our dream car, but we're seeing demands of customized products and personalized products popping up everywhere. I've seen it in trainers and even earphones, in-ear earphones, that you take a picture of your inner ear and get a personalized product. The common thread here with these sort of online configurator is often consumer-facing products. It's sort of almost expected these days. And I'm not sure if anyone on the call is consumer-facing, but I guess it's a driving force. We actually see most manufacturing businesses being able to see some form of automation, really giving them an added advantage, even if your products are truly bespoke. Yes, perhaps your products are different every single time, but I bet fundamentally they're based on the same underlying design principles. And what if, instead of starting from scratch each time, or perhaps changing the last design, you could get to 80 or 90% of the design done at the click of a button, and then just tweak it on top to suit? Anything that a click of a button can do to whether it's adding extra holes when a product gets over a certain length, or adding extra stiffening bars, and it can create it automatically. It's amazing to see, and I've got a couple of great examples of customers that we've helped in recent years. Well, these are the ones that I'm allowed to talk about. Often a lot of customers that implement an automation solution don't necessarily want the competition to know about it as their competitive advantage, but these are a couple that I can talk about. So one of our customers manufactures fire doors. Pretty simple, right? But there are so many variations and options. The process for them was pretty much one, I guess probably a lot of you on this call could relate to, in that the sales guy would spec up the configuration with the customer. They'd go for the design team to design that design, make the necessary changes backwards and forwards with the customer, and then process that through manufacturing. It sounds pretty simple, right? And up until Grenfell Tower happened, it worked for them. But after Grenfell Tower disaster happened, unfortunately, Moreland expected to see an increase in sales by a factor of 9. And with a small design team, they kind of understood at that time that the bottleneck was always going to be the time it took to create the design and make those customer backward and forward changes. So without increasing the size of the design team at all, which would obviously have an effect on their profits, they wanted to work with us to create an internal configurating tool that, with all the options, all the variations, including all of the rules that go behind it. And now they can configure a custom design, automatically create all the quoting documentation for the sale for the customer, as well as all the manufacturing QR codes to route the product around the factory within 2 minutes. And now they're really reaping the rewards of an efficient sales to manufacturing process. As well as that, the designers now have a bit of time, I guess, to focus on real innovation and new product development. A really great example of how internal configuration with Ilogic can help customers really push forward their sales process. Another great example is a customer who lead the way in GRP building components, mainly for home builders. Now, they already had an efficient Inventor and Vault workflow team working quite well, but they were starting to be asked for BIM data. Now, any of you on the call that manufacture components for the construction market know that BIM data isn't just a 3D model. It's actually a simplified version of the model with all the metadata included in it of what that product is and does. Now, Storm King already had the models in Inventor and stored in Autodesk Vault, but no real way of pulling these two things together. Now, originally, they were considering buying a construction design tool like Autodesk Revit and actually training the design team to effectively redesign for BIM, as well as the manufacturing design. Now, this would not have been a good use of time. So we worked with them to create an automated internal process that at a certain point in their design process would create, simplify, and pull all the right data into the file to create a BIM file. Now, it's all triggered by that tool I mentioned earlier, Cool Orange. So the designers can now just continue the normal process of designing great products, and the BIM data is simply created in the background, ready for the customer, for the sales team to give to the customer. So there is a lot that automation can do, more than just a online customer car configurator we all think about. You need to think about your products. If you are repetitively designing versions and variations of your products, and you can describe to me or to anyone what changes in the product and the rules that define the product, then Ilogic might be the right tool to make your process quicker and easier, and of course remove the human error factor. Now, I'm going to hand over to Chris England, and he's going to take you through how easy it is to get started. Chris, are you there?
Yeah, good morning, everyone. So I'll just start with a little bit about myself. I'm an application engineer for Man & Machine. I've been here a couple of years now. I don't know when last I updated this slide. It doesn't look like it shows. It's okay. So yeah, I've studied in mechanical design before this. I've been an application engineer for quite a few years now, and I also spent quite a bit of time in the design office before that, working in the water treatment industry, a lot of sheet metal and pipe work and that sort of thing. My Autodesk products of choice, I suppose, although there's quite a few more that I can use, would generally be Inventor, Fusion 360, AutoCAD, and Vault. And yeah, any design automation, subtractive, additive manufacturing, or generative design topics, I suppose it does branch out quite a bit more to, like, visual design and all the rest. But yeah, multiple interests within the manufacturing industry and market. So I'm just going to jump over to my screen. So I'd just like to start by mentioning that this is a re-recording. Unfortunately, the original webinar didn't record quite as we planned, so we're just redoing my part so that the Ilogic scripts and all the rest that I'll be showing come through clearly, as the resolution was a bit low. So to start off, we wanted to show what a configurator may look like. I suppose, we all use, well, a lot of us use Ilogic already, and we use it for many purposes. And the goal would always be to be able to create an Ilogic configurator that is from end to end, from modeling and creating and putting inputs into our model to producing our given outputs, whatever they might be. It might be scripts to ERP, it might be drawings, it might be DXFs, it might be bill of materials. It could be anything that we're trying to output at the end of the day. And I suppose we also might be using Ilogic for various parts of our design, but not maybe the whole thing. So I wanted to sort of show off, start by showing off a end-to-end type configurator. I've got a simple little tank configurator, which I'm going to show you. So I'm going to start off by opening my configurator part, which is essentially just a decoy part, if you will, that has opened up its form on the wrong screen, and allows me to either create a new configuration or open one. Now, as I go along, I'm going to show you. All of this is contained within a folder. It can be called anything. In this case, it's called Tank Configurator. And in that folder, I've got my jobs, I've got my template, and the part that we see with the project file. So if I go and say new configuration, once again, wrong screen, we will go and type in a project name, and we'll call it 001 as a tank number. So if I say create, and I go have a look in my jobs folder, we'll now see that there's a project and a 001 where my new job is then populated. So what we can then do, I mean, my tank in itself is not too complex. It's a pretty simple Ilogic part. I will be giving this data set over in the comments. You can probably find a link to it. And you can then try work along with me with some of the things that I'll be showing. There are some free rules there for things like DXF flat patterns and other small things. So I'm going to give my project a project name and a number, and you can change the author if you like. And what I've got here up front is a max sheet width and length. So having worked with these sort of buffer tanks in the past, one of the limitations that we hit is often the size of the plate that we can buy from our suppliers. So the largest parameters that I suppose we can meet from our supplier's actual sheet will dictate the size of the tank that we can ultimately build. So in this case, I've just got it set to 1,500 and 2,500. I'll show you how the limitation rules work, and I'll actually even show you how to create one later on. So if I go and have a look at my length, what it currently does is we've got from my overall parameters, the width actually stacks along the length and along the width of the tank. And I've used the length of the plate as the height limitation. So for example, if I went to a height of 3,000, I would then get an error. Maybe on the other screen, there we go, there's my error, saying that the maximum limitation is 2,500 based on that plate size. And then what it does is it just sets it back to the maximum and pulls it down there. So if I went and set that to 1,250 rather, it then is happy to do that. The other thing I've got is the ability to either have one or two plates stacked on the length. So if it goes below the width of a plate, so we'll just make sure it's smaller. We'll go to 1,200 and we say okay. It actually takes out the parts that are then not required for the extension, adds extra miters on, and moves the tank into place again. And you can see that what it's doing is in the assembly, it's actually suppressing those parts. I'll put this back to 2,000. Let's just go to 2,000, I guess is fine. And we can also change the width if we wanted to. So I'll go to 1,350 and say apply. So with that done, it'll add back in my parts, and you can see that all the unsuppressed parts. So I've got this. When the unsuppressed part needs to rerun after suppression, I've got a bit of a fail in my rule, but it's okay. It wouldn't be a good demonstration if there weren't small errors in it, so I'll just let that re-update while the parts are available. I can change my plate thickness, so of my actual plates. If we have a look there, let's see, it's not easy to see a plate while we change it, but we can maybe go and change that to 5 thickness. You can see it's a little bit thicker. I can change the size of my angle iron. Let's go to 35x3 on the sides, which makes them a little smaller. I can also change them on the inside as well. Just change the thickness there. So just try a watch. I should have maybe changed the colors of my materials, but we can see it gets a little thicker, thinner there rather. And so, yeah, it's a very simple model, as I said, a good training example at the end of the day. And so I've got my nozzle that I can maneuver. So firstly I can turn it on and off if I don't want a nozzle at all, which then just goes and suppresses both my flange and my nozzle. I'll turn it back on so that we can have a look at some of the other things that we can do with it. So I can change my nozzle length to 200, for example. I can change my pipe thickness, and I can also change my nozzle size. If I change that to whatever it is. So changing it, well, don't want a nozzle that long, it will happily do it, but I don't think it's a bit excessive. So I can also change where the nozzle is positioned on the plate, and what that actually does is changes. So I'll change my offset from center, and I'll change this to 300. Or I could set that to leaving the height and maybe set it to the center. Oh, sorry, we don't want the height to change. Let's change that back and change my offset to the center and say OK. So what that's doing is just moving the hole in the plate as well as the positioning of the nozzle. So a lot of this is pretty standard parametric stuff. It's not, like I say, the most complex of models, and that's not exactly what I wanted to be showing off today, although I will show some of the things required to create this model, and like I say, there will be a data set that you'll be able to download and follow through with if you want to. Other than that, it might just have some handy rules in it that you might be interested in. Either way, what we really want to see is the outputs, or I suppose, configurators are great, and having Ilogic models is great, but being able to produce outputs is generally where our time consumption happens as designers, detailing drawings, or I suppose creating the drawings so that we can detail them. Creating things like DXFs from flat patterns is a horrible thing to have to do, very manual, very mundane. And so what I've got here is just a couple rules that I'd like to show you. So firstly, if I just save my configuration, I can go and create DXFs. So I want to get up my folder before I do this, just to show you that it is happening live. So I've got a DXF folder in my jobs folder, and I'm just going to go and say create DXFs. And essentially what this rule will do is going to go and look through each part, find out if it's a flat pattern, if it's a sheet metal part. Now my sheet metal parts aren't very fascinating on this, but this rule essentially would work for just about any assembly. As long as it's an assembly, it'll look through all the parts within that assembly. If it's sheet metal, it'll make a flat pattern and it'll export it to DXF based on a couple properties within that model, and give it a name and put it in a folder that you specify. So I've left that rule in there for you guys. It is a quite a common rule. I can't remember where I got it from, but if it was you that created it originally, it wasn't me that created it originally. I took the code from online, so thank you for the help it's given me, and hopefully it'll help the rest of you guys as you go along with it. But yeah, you can stack that as a external rule that you can always just have available, and on any assembly that you want to create all your DXFs for, you can just run it and it should just chug through all your parts within your assembly and make DXFs of anything that's sheet metal. So very nice rule that for some outputs, and yeah, we get all of our DXFs there as well. Now the next one is to create a drawing. So also within this model, I've got a drawings folder. There's some template drawings. Of course, there has to be a drawing for it to produce it from. And I've also got a PDF folder. So we'll go and run our create GA drawing rule, which will just go and open up the drawing template, neaten up my dimensions, and produce the drawing, save the drawing as, and also go and create a PDF for me in my PDF folder. So there's my drawing. I can go open that. It's an inventor drawing. I could, you could have AutoCAD drawings or AutoCAD versions of the drawing if you wanted. You can have various different things there. And also I have a PDF which has been created, which is always a nice touch for the non-CAD users in the office. PDF's also available. So there we go. A nice drawing created without any effort. So, and that's now a unique project that's not linked to my original. It's obviously all linked to its own parts, which is in itself handy. That project will sit in its own folder and work like that. Then the last little rule within this, and I'm going to just get my form back up. Of course, it'll go on the wrong screen. And if I go and have a look at my outputs, I've also got one more rule, which is also my bill of materials. Now, my bill of materials, and I'll show you guys how this one works. Essentially, it runs off of a drawing bill of materials rather than the bill of materials that we have available within the assembly environment. The reason I do this is it's easier to negotiate it with levels of detail. When we work with level of detail, the bill of materials rules are a bit trickier. So if you just create a parts list, it works out a bit better to extract it to Excel. But if I go and have a look, there's my parts list over there with the same details that it shows on that drawing. So essentially that is my end-to-end configurator, or an example of it, I guess. It's got a couple of the outputs already stacked in it. It's got the ability to copy folders, which is always going to be handy. I mean, there's lots of options that you guys might want to look into, things like linking Excel spreadsheets and doing driving from Excel, perhaps, or perhaps having a non-CAD user input parameters into an Excel, having your model pick it up or a server pick it up, and then configure a model and spit out the output somewhere else. There's so much you can do. It's really an open-ended field, is Ilogic, and you can really get a lot and achieve a lot with it. So that all being said, what I want to do is I want to show you, after seeing the big picture, I want to show you just some of the steps within the process to get into this point and being able to create a model of this nature, or I suppose starting with the model, as that's the backbone of a configurator. And then we'll look at some of the more advanced stuff and I suppose putting together the actual assembly. So starting off, and if you want to follow through, it's quite an easy part to do. It might be a little too easy for you guys, but it's a nice little example to test on. So I'm going to start with the sheet metal part, and I'm just going to start with the normal sheet metal template and start a new part. And what we're going to do is we're going to create a flange. So before I do that, I just want to switch my projects to the one from the data set. So I'm going to go and create a new part. And it's a sheet metal. So first things I want to do is I want to just go, and you can set your materials up and your styles and standards. What I'm going to do for this example is just untick my use thickness rule and set it to a default of 3 for now. That's fine. So we're going to go through an exercise or a process of creating a parametric model, which is obviously the foundation of Ilogic creation. At the end of the day, we start with parametric models or parametric parts that can then be scaled. They might have rules for things like suppressing holes or suppressing features, or perhaps lots of other things, creating materials, changing thicknesses, changing whatever you might want to change within that part. But then we end up at the assembly stage, where we can then go and produce downward effects from that assembly, or drive it from the assembly into the parts. So we're going to start with an initial part, and we're going to try and recreate the flange that I've got within my nozzle. So I'm just going to start a sketch on my XY plane, and before I do anything within the sketch, I suppose I could have done it before the sketch, is I'm going to create some user parameters. So I'm going to click on my parameters button and go and start by adding a couple numeric parameters. So I'll start with an ID. Anything in piping, you've got IDs and ODs. Fine. I'm going to go for a pipe size, or I suppose pipe size, or I could make, pipe size. Could be nozzle size, it could be whatever you want to call it. And we'll go and add a thickness. Well, we've got our thickness, so we don't actually need to add it, so I'll scrap that one. We've got ID, OD. We want some hole sizes. Oopsie. Hole size. So just remember, with creating parameters, the rules are you can't have any spaces. You can use underscores if you want a space. I normally just start with a capital letter on each, and it's always a good idea to have a system for working with parameters. Naming them in a systematic way will just mean that if ever you forget something later on, you can probably remember it a bit more easily. But we can also, there are other ways that I'll show you throughout this demonstration. So with my whole number, I always call it whole num, but with my whole number, what we need to do is change it to unitless. So I've just clicked on the unit, and I'm changing it to unitless. It will not update automatically, so we just need to type something in there just to get it to automatically update. Always a good idea, if you're creating your parameters up front, is to set some default values. So we'll type in some values just to make sure that we don't end up with a 1 by 1 by 1 by 1, whatever it is we're trying to build. Pipe size, In this case, that can just be 150 for now, and we'll change our hole size to 12, and we'll change our hole number to 8 for now. That's fine. Right, so with those, I can go and start my sketch. So I'm going to just draw in 2 circles, snap into the center, and I'll start with ID, linking the parameter to the my parameter within my dimension to my parameter. I'll make another one for OD, and in this case, I'm just going to, there's one that we need to add one more, which is PCD. Now I'm going to just keep my PCD as a straight line, so it would be divide 2 of the actual PCD. We'll make it 80 for now, it's fine. Okay, so what I'm going to do is I'm going to create one sketch here just to speed things up a bit and keep it flowing. So I'm going to make my whole detail within the same sketch for my extrusion. I'm going to create that and make that into a construction line. I'm just going to dimension this, and I'm going to place my angle. My angle is going to be the first of my equations, which I'm going to create it as 180 degrees divided by whole number. Right? Whole num. Now, as I mentioned, if ever you do forget a parameter, you can always just click on your little arrow at the end of any parameter field that you're trying to input and just click list parameters, and you can find a list of all your custom named parameters. So if ever you forget one that you typed, or perhaps you made a typo and can't get it right yourself, you can always just go and click that arrow and find it there. So that now spaces out my hole. As I do like them to straddle the center line, even though I suppose we could just constrain them however we needed to. And I'm going to make this PCD right there, and I'm just going to put a point right at the end of that line. I'm also going to make this line a construction line as well. So that should be fine for now. So that's my first sketch created, and all I'm going to go do is finish that sketch and create a face out of this outside profile. So we have our flange profile. At this stage, it doesn't matter which offset direction we use, but always be mindful when creating Ilogic parts to just consider where your origins are going to end up and why you want them to end up there. As I'll mention when we get into the assembling environment, that I very much believe in using your origin planes for constraints, even though it would be easier to just use parts. It means that if we turn in on parts and turning off parts, that if the part that something is constrained to gets switched off, it doesn't necessarily break the constraint. Anyway, so next we're going to do is we're going to turn on the sketch visibility just to be able to reuse it, and we're going to go and create our hole. So if we go create our hole and select it, you can see that I've already done this before with hole size. So all we want is a hole that's through all, using hole size as the diameter. It doesn't really matter that it's breaking the wall right now. We haven't really set up any of our parameters yet. Okay, so that's pretty much our flange. We just need to pattern our holes with circular. Patterning always a trick. Select it in the browser if you can't grab it or get to the face of the hole. Rotation axis, selecting the center, and we want to make sure that our occurrence count is set to hole num, like so. Good. So we pretty much have a parametric flange now. It's ready to be driven however we need. Oopsie. I'll just bring that back onto the screen. And so ID can go to whatever it needs to, OD, whatever it needs to, and pipe size is not linked to anything yet. We could change our hole size though. We can change our hole number, which also keep them straddling the center line due to our angle rule that we added. Okay, so with all of that, and it's a horrible looking flange right now, but I'll turn off my sketch visibility. And obviously with something like a pipe-in or a pipe-in flange or something like that, we obviously have a spec that we would work to. So in this case, we want to go and quickly go to our parameters. Our pipe size is going to be what drives it. So I'm going to make that into a multi-value parameter. Now the benefit here is that it'll have a list of parameters that I can use, and anything other than that, so I'm going to say 100, I'm going to say, what do we have, 100, 150, 200, and 250. So I'm going to add those parameters in there. You can also have a custom value. In this case, it's not going to help us because of what we plan to do. But having a drop down just means that people or other users, I suppose, that didn't create this can't go and type in a value that doesn't exist or perhaps might break your model. So always a handy thing to have is a drop down with a multi-value. And if I go to my Ilogic tab, so to get to the Ilogic tab before I jump to any conclusions as to how we get there, we can go to Manage and we can get to our Ilogic panel, where we can find all of our Ilogic tools, or we can, in the newer versions of Inventor, we can just click on the little plus next to our model browser and find the Ilogic tab there. Or the Ilogic browser, we can bring it up by clicking that there. And then what I normally would do is just right click in the rules area and say add new rule, but once again the button is up there. So if I click add new rule, I get a new little window, and this is how we then access our Ilogic rules. So we're going to call this rule size, and we can now go and create our standard rules. So this is what the Ilogic window looks like. For a lot of users, I think looking at Ilogic for the first time, we get quite intimidated by the fact that it's coding and it's got some rules and it's Visual Basic based, but it's not that hard. Once you get used to it, we have all of our snippets available to us here. We can find, well, not all of them. There's lots of things that we can do that aren't probably available here, but for the most part, the easier functions and the functions within, modeling capability that are built towards Inventor can be found within these snippets, and we can find lots of things here. So what we want to do in this one is we want to simply go and change some parameters based on an if, then, end, if rule. So you'll see over here we've got a couple little helpers. I'm going to add in an if, then, end, if, and I'm going to go and type in my parameter that's going to drive it. So in this case, I can go to my user parameters up here, find my pipe size and say if pipe size equals, and I can then go, I don't need quotations for this one, 150 for example, something must happen. So I could then say ID equals 150, for example. Now I think, if I'm not mistaken, I've got a snippet for this here, so I'm just going to bring it in because it's going to save us some time. So there we go. So we've got pipe size 100 equals, well, if pipe size equals 100, then this must happen with my OD, ID, PCD, thickness, and all the rest, right? And I'm just going to scroll down slowly. Please feel free to pause the YouTube video and type them in as you need. But there we go. So we've got all those sizes, and if we go and say save and run, we can then go and find our pipe size value. And now what it should do is, based on the different sizes, change it up in those increments. Now, of course, a lot of you might think, why wouldn't we just use an iPart here? Well, when it comes to piping, in fact, iParts are very handy because they're table-based, they're not open-ended. So, well, a lot of them are table-based. Obviously, we get specials and customs and whatnot, but because of that, it is quite ideal for an iPart, but this is just, I suppose, an Ilogic demo. So we can do it with Ilogic or iParts, the difference being that at the end of the day, Ilogic would probably give us a bit more functionality, whereas if we went on an iPart, we'd have to go row by row. It is that, so if I double click on that row, these are the parameters, whereas Ilogic gives you a bit more flexibility. Anyway, that is our Ilogic flange created. So I'm going to go ahead and save that. And where I want to save it is in my template folder, in my parts. And you can see that I've already got one there. So if you don't feel like making it or didn't quite crack it, you can always go have a look at that one there and sort of see where and what went wrong. Remembering when we work with Ilogic and parameters, typing and spelling is essential. You've got to get everything 100% right. So the smallest typo can drive you mad. I do know this. Okay, so with that done, that's just a general part creation. I mean, there's lots we can do. There's tons of snippets there. Suppressing features, we could suppress the holes. We could have holes on and off with a true-false statement. There's lots of things we can link, but unfortunately, I don't have time to show too many more of those. So we're going to jump into the assembly now. So if you use your data sets and open up the template, and we'll find our tank assembly in the root of that template. So opening that up, you can see that I've created the tank for us, and most of the rules are already there. So once again, very handy to go and review and see what is there and what rules I've used if you are new to Ilogic. I just wanted to show the angle that I've created here as well, just because it's got some size rules, so much the same as what we've just done with the flange. We've got a size. I've used case in this case, but yeah, so it changes the side parameters and whatnot. But what it does have as well is the ability to switch holes on and off. So you can actually turn holes on and off. So there's a nice example of a suppression rule there, and we do have our size rule as well. Okay, so have a look at that when you get time. If I jump back to my model, it's probably gone, I've probably broken it, but if we just rerun our reference rule, we should be fine. Okay, so the gist of it here is that we're going to bring in our flange and add it to our nozzle. We're going to be a little lazy, we're not going to use parameters completely. So if we just go and say place, we can go to the template folder, find our parts, and add the recently created flange. Now, I forgot to add a material there, so it's possibly just going to be generic versus whatever else the rest of the tank is, but that's okay. So if I go and constrain that into place, and like I said, we're not going to worry too much about origins and all the rest. We will need some of the origin planes, but we won't be too sticky on it. And if I remember right, yeah, so we're going to need to place that back with the correct parameter as well. But for now, we'll just go and constrain our nozzle into place, and using an insert, we'll just do it the easy way. Place it there, flip it over, and probably give it a little bit of a weld allowance in the front there. So that's okay. Don't worry if it's not the right size either. If it's too small or too big, it's okay. It's just going to be based on wherever you left it. We still need to link it. All right, so with that done, we want to make sure that our holes straddle the center line because they can still rotate. So we're just going to quickly use the origin of our nozzle and the origin of our flange and expand the origin folders, and we'll just use two of the planes just to make sure that it can't rotate anymore. That'll be fine. We'll just use the YZ, it's the YZ, and then we want to take the XY plane of either the flange or the nozzle, and we want to go and match it with the mid plane of our overall origin. So this is how we should be constraining just about everything if we can. As long as, you can use part-to-part constraints as long as those parts switch on and off together. If they don't, then you might run into problems in the future. Either way, there should be a parameter, so I can't remember now. So we're going to go and say list parameters and find the side plate offset, pipe center offset, I would imagine. So we put that in, it brings it to the side we want. Just remember you might need a flush or a flush or a mate accordingly. So that's now in place. It looks like neither of those parts are moving, so that's fine. Okay, so obviously placing it, I'm sure most of you can constrain, and now look into some more advanced things. So hopefully we can inspire that thirst for knowledge a bit. So what we need to do firstly is, of course, if I go to my form, I'll show you that currently, if I change my nozzle size, which we have the same parameters, and I go change that to 100, we have the problem that the flange is now not linked. So what I normally do with assemblies, or Ilogic assemblies rather, is that I have a rule, normally my first rule, that's called reference. And all this rule does is it goes and takes a parameter and filters it down into a part. So pretty much it's a part. So we can see that we've got this code parameter, the part name, whatever it is from here. And if you need to bring it down, you can always just click on name and find it there. And then the parameter we want to link with the parameter from our assembly that it's linking to. They don't have to be the same name as long as they make sense to you. So if I went and did this from scratch, it would look something like this. I would be able to go, and I have two options really. You can go and get the actual snippet, which I don't see right now. Give me a second while I spot it. There we go. Parameter assembly. So you can double click on that snippet over there from your parameters folder, and it brings in a default or generic sort of name and numbering. I can go and select that and then go and find my new flange, and if I click on the names tab, I'll find flange and just double click in, bring it in like that. Then I need to find the parameter I want to link. So we only need one parameter going down into this. If I expand flange here, I'll find that I've got some user parameters. Now I need to be on the parameters tab, and I'll find all of the user parameters. So I can just double click on the one I want, pipe size in this case, and you might note that in this case it brought through the whole parameter mapping. So I can use it just like that, or I could simply type in pipe size. Always be aware that if you type in, typos and mistakes can cause you headaches later on. And in this case, on this assembly, I've actually called it nozzle OD, I think. So we want nozzle OD to come from there. Just to show you how that would have looked if we had just brought it in straight, we would have found the parameter we want, double clicked on it, and it actually maps it to the part already because we're pulling it from the part there. So probably the easier way to go, but just so you see both ways. I just want to make sure that that nozzle OD is the right parameter to be using. Nozzle OD, and it's the multi-value there. Yeah, so nozzle OD matches pipe size. So like I said, they don't have to be the same parameter as long as they're expecting the same values. And always remember that text versus numeric versus Boolean. Just be aware of the field that you're trying to input into that parameter. Okay, so now that's linked. So the reference should just keep it in sync. So as I change it up, it'll keep the nozzle, the hole, and the plate and the flange all in sync. Once again, there we go, cool. And we'll double check that our hole center, our pipe center is working, so we'll set that back to 0. There we go. Thought for a second it wasn't going to, but it has worked. So that is the gist of creating a reference rule, and obviously I've created a lot of them for you here, but you can always use it as an example. What I try to do is I try to stack each part together. You can use, within Ilogic, you can always comment out things. So I could say, this is for side plate. And there we go. I've got a comment there explaining what's going on there. I've sort of used the same format for a long time, so I don't generally explain, but it is always handy if you feel you might forget, or perhaps you're not going to look at this model for a couple of months, maybe years, and you then want to work out what you were doing back then. Okay, so some of the other rules within this assembly, because you'll be able to check them out in your own time, I'm going to hand it over as is that I've got a side angle size rule that just follows the same as that same rule that's within my angle eye, and the only thing that it does is it just gives this parameter a sizing so that I can adjust the offsets for the various angles as I sort of scale them up or scale them down, as they need to sort of offset from the edge to meet up with the mitre. Oopsie. All right, the next rule we have is the size limits rule. So I'm going to just go and delete this little bit here, and I'll show you how we did it. So with these limits that I used, now remembering that I mentioned them in the beginning of this demonstration, is that we have a max sheet width and a max sheet length. And what we want to do is we want to create parameter widths. Now within the Ilogic window, we have some wizards that we can use, where we can actually go and set our parameter limits. So if I go and click parameter limits, I can find this window that pops up, and I've just left it on the default. You can change the texts for the max violation and minimum violations if you like. For the purpose of this, I would say let's just set it to length. And we want to set up a length one. So you've got to get your parameter name right. Once again here, it'll write it in, so you can always just copy and paste over it or edit it later on. And we want to set our minimum and maximum accordingly. So we want our minimum to be 480, and our maximum for now we're going to say 1500 as is. We'll say apply, and you'll see that it actually brings in all of that code for you. It comments out the little starting comment, as well as adding in if length is less than 480, then show me the message box, and it also sets it. It sets the length to 480 and shows you a message box saying that it's both doing that and you've exceeded the limits, or gone below the limit. And then also we have length here, and what we're going to use is we're going to use the max sheet length. So remember I told you, max sheet width. I told you that the width and the length were linked to the width of the plate, maximum width of the plate, whereas the height was linked to the length. So if you just copy that max sheet width, or even type it again, and we're just going to go paste it in there and paste it in there, so that now it's linked to a live parameter rather than a static one. So we can say, okay, well, I've got a new supplier and he can get plates that are 10 meters by 2.4. I can then start working with that as my parameters, rather than it being set by a default, and then if things change in the future, you can't allow for that. All right, so that is our wizard and how we can create those rules quite quickly. There's a couple other wizards that you can check out when you get some time. If I say save and run, it's pretty much, and by the way, that rule is there already. I'll leave it in there so you don't have to create it again, but if you do try out the wizards, they are very handy. Then I'll just show you my extra side plate rule. So this is the rule that actually does the suppressions of the parts. Now, suppression comes with a warning in assemblies, and I'll get to that in a second. But essentially, it's quite simple. If length is less than max sheet width, so remember we just set up that limit there. So if it's less, then we don't need all the extra parts. Greater than or equal to, we do want the extra parts, right? So then I set all my plate sizes. So this is some of the reference rules that we spoke about there, that I've moved out to this one because it needs to be driven by the rules. So if it's needs to be a double size, all of those plates need to become half the length minus some extra values that come into play. So some of the angles need to be shorter, and the plate and base plate need to be halved. And then we bring in extra side plates, extra base plate, extra angles, extra internal angles come in because we need to join those two plates. And then we've got some compensation and parameters that just set themselves correctly. We also have a mitre rule within the angle irons that allow for it to either have a mitre on both sides or one side. That's the mitre one that I have there. Then we've got, if the length is less than the max sheet width, we have side plate offsets is set to 0, so we have no offsets there. So pretty much it moves the side plate to the middle and starts turning off. So component is active, the component name equals false, so it's not active anymore. And you can actually find that snippet if I just go down to the bottom here, and we can find it in components classic is active. Double click on it, there's the part, and you just say equals true or false. Nice and easy. Another way to get to that point, although it tends to be a little messier sometimes, is to right click on, if you do it in a feature in a part, it comes out with all the features, parameters and such. But if you just right click and say current state is active, it brings it out whether it's true currently or not. Now, the little caveat that I have for you. So whenever you deal with suppression within assemblies, you have to be aware of level of detail. Level of detail comes into play when we look at suppressing any part within an assembly, really. So if I go to my master level of detail, okay, we'll need to save, that's fine. You can see that all my parts are now switched on. They're all a big mess and they could be all over the show. If I wanted to let one of my suppression rules run, it gives me the error that it cannot change the suppression state because there's no active level of detail. So just be aware that you need a level of detail in order to have any sort of suppression within your rules. And I'm just going to activate my Ilogic. I normally just create one quite simply by right clicking on level of detail and just saying new level of detail, and I normally just name it Ilogic because it makes the most sense, but you could call it whatever you like. It doesn't have to be called Ilogic for Ilogic to work within it. As long as you have a level of detail active, you can then suppress and unsuppress parts as you wish. So bear that in mind. It gets a bit trickier as you start stacking up the extra things that you're trying to do. Like I mentioned earlier on, that the bill of materials, if you got a standard or created a standard rule to just export the bill of materials from this bill of materials, often enough the level of detail plays a bit of havoc there, which is why I use the method that I do, creating a drawing with a parts list and then using the rule to extract that parts list, which, by the way, I've left that rule for you. So I've got a few more rules to discuss with you, and then I'll sort of, I suppose, talk about a couple of the more advanced things. We'll create the bill of materials drawing, and I'll walk you through the DXF flat pattern rule that I've left for you guys, that you guys are welcome to use from now on, and show you some form setup and whatever else we may have time for. So looking at the form trigger, we've got a simple rule here. Once again, straight from one of the snippets, I've got forms. Where are you? Forms. There we go. Forms. Show form. Double click on it, and it brings up the simple rule of ilogic.show, open brackets, the form name that you want. Now, the only thing that's required here is to make sure that you know the name of your form and you type it correctly, and it'll work. So if I just say save and run, boom, my form pops up straight away. So all I've got that here for is to then set to what we call triggers. So one of the other stages of Ilogic, I know I'm brushing through a lot of the general stuff here, but obviously there's way too much that you can do with Ilogic for me to show in a 2-hour webinar. But if I go to my, manage, and I go to event triggers, you can see that I've used some triggers here to set up certain events. So for example, whenever I open, after open document, run form trigger, i.e. whenever I open this model, it'll pop up with the form, which is just a nice finish. I suppose you don't want to have to click form if this is, all that model does is use the form, drive it, outputs, or whatever else the form does. You don't want to have to click it each time. But on the other hand, it can be tricky because now whenever we open a drawing, it opens the model, which then opens the form, which can error things out. So just bear in mind that is it's a nice one when you're working with just models, but if you start working with drawings, you might want to consider some other routes or options. So just quickly on those event triggers, there are other ones. So before save, after save document, close document, when any model parameter change, property changes, there's lots of triggers there for events that we, normal functions with Inventor that we might want the rule to run when that happens or just after that happens. I also have save configuration, which is just a simple rule once again for saving. I think it comes out of document, this doc.save. So if I double clicked on that, it brings in that snippet. And essentially all that does is it just saves the document. So that just makes for a nice button on a configurator because of course we open it up, we change its size and different variables, maybe suppress some things or whatever. And before we go and create anything else, we may want to just save the document, and it's, to click save when you're already in a form just seems a waste. So I then have my create DXF and create bill of materials, which I'll get to in a second. If we have a quick look at our form, you'll see that outputs in that save configuration button that I was talking about. So having a quick look at creating a form, you can create a new form by saying add form. It all works in this window here. Sorry, once again, popped up on the wrong screen. I'm not very prepared here. And give your form a name, which will then be the name that you would use for that trigger form. We can just simply drag and drop whatever parameters we might want to see on our form. You've got some extra little tools down here like tabs or groups or adding a picture if you want. picture folder. There's splitters and labels that you can add to it. So you can add a lot of things. If you wanted to add in any rules, you just drag and drop a rule quite simply. Just drag it into your form and it becomes a button. So it's quite nice. We can do eye properties as well. So you can do straight eye properties into a form, which is always a nice touch. If you have particular eye properties that you want or need to fill in on every document you create, you could create a simple form with those eye properties listed, have it trigger on every document or every time you start a new document or something like that, or when you open a document, and then you can fill in those eye properties and you won't forget on your designs. So yeah, creating forms, pretty simple and nice environment to create them. And so what I want to do next is I'm going to create the bill of materials. Now, having a quick look, I just want to open up a new folder and find my, not documents, we want tank configurator off my desktop. So let's go to the messy desktop, find the tank configurator. Webinar dataset, that's the one. Template. All right, so from here we've got a bill of materials folder, and I've got an example. We're just going to delete that and delete my parts list. Right, so I've left a bill of materials example for you here. For my rule to work, and in fact for a lot of my rules to work, following this folder structure may be handy, but I will try and navigate you to how you can control those folder structures, or hopefully I'll have commented the rules that I've given to help you with that. Either way, we're going to just go and create a bill of materials drawing and put it in that folder. So if I go and say new, I'm going to use my man and machine title block. You can use any title block. In fact, what I would normally do is, if it's just going to be for bill of materials, is even delete the title block in the border. So we can delete those, and we can then just go ahead and place a parts list. Now, know it or not, you don't have to have a drawing view to place a parts list. It's just one of the ways to place it. And there's that rule that I mentioned with the triggers. So as soon as you open a drawing, it's going to populate or pop up with the form. So like I say, it's a handy one to have it on a trigger, but sometimes it can be somewhat painful. All right, so I can then go and just place in my parts list. And remember, you can go and edit that parts list and add whatever fields you want to it. So adding in, descriptions or stock numbers or whatever's important, material, mass, anything like that can will be. So whatever you see in here is what's going to export to Excel. So customize that, get that ready, and we can then just go and save this. Now for this example, I want it saved in bill of materials, and I want to just call it simply BOM. Make sure you're using a DWG template, and IDW won't work as well. So we save it as the BOM, save it in there, and it's good. Now with that, I can then use my bill of materials rule. So I've got this create bill of materials, and quite simply, now I suppose this is where the what I consider the divide in Ilogic comes in. So we've obviously got the simple code, the basic, the Visual Basic stuff that allows us to control things like switching features on and off, parts on and off, suppressing constraints or anything else, changing the color, changing the material, changing eye properties, parameters, driving parameters. That sort of stuff is where we get all of our snippets from. And then a bit further along, we end up with some code where we start referencing documents and start making calls to dimensions within the rules. And this is, I suppose, a little more advanced. It's not a very complex rule, but I have added a few things for you guys here. So essentially, we've got this dim the O drawing as invented drawing document, and this application document's open, and then it opens a drawing file, which is going to be with a parts list on it. It must have a parts list for this to work. And currently it's just mapped to this document's path and that folder. You can hard code that as well. You could say C drive temp or whatever you wanted it to be, and it would find that drawing there. we can then say, it says update the drawing, dim inventor sheet. So obviously we've got multiple sheets in the drawing, so we're just dimensioning sheet 1, and we're just saying take the parts list, or dimension the parts list equals on that sheet 1 parts list 1, and pretty much it then just goes and grabs it and exports it to Excel, putting it once again in the folder name, which comes from our document path, and we just go and put it right next to the drawing essentially, and folder name is this doc.path, and in bill of materials once again parts list Excel. So I can go and call that free BOM rule, and I can go and say save and run, and what it's going to do is open up that bill of materials drawing, extract the bill of materials, close the drawing afterwards, and if we go and have a look, we now have a drawing there. So you can quite easily customize those things, customize the locations that it saves it in and whatnot. I'm going to change that back so that it doesn't. We'll just delete that and call it BOM. So yeah, where you want it to output is probably the more important one. Obviously the drawing that you grab in, as long as you keep the same format and always put your bill of materials in a folder called BOM, that would always work. This one, you could hard code that to maybe being on a server or whatever it is you want it, your bill of materials to be exported to. So I'll save that and leave that as is. Great. So I don't have too much more time for today. What I want to do is just show you the DXF rule that we have. I'll show you how you can make it into an external rule for your own use and use on any assembly, even if it's not an Ilogic assembly, even if it's not even prepared to use this rule, you can use it. So having a look at it, create DXF. And what we've got here, so to just try and break it down a little bit, once again, we're dimensioning documents and naming everything, or defining everything that we're going to need. We have here, if the active document type is not an assembly, it's going to pop up with a message saying that this rule must be run from an assembly. So very important, you want it to run from the assembly. It's pointless doing it from a part, as you know, running a DX or creating a DXF from one part is easy, but from an assembly with 100 sheet metal parts will take you a lot longer. So this is the kind of rule that we want to be able to just start, go get a cup of coffee, come back, and our DXFs are done. Then there's a bunch of stuff here for a message box, pretty much asking that if you run this rule, because you could trigger it by accident or something, are you sure that you want to create DXFs for all the sheet metal parts in the assembly? Because it might take some time. So once you start, there's no real stopping other than killing the inventor process. So obviously, if you deal with assemblies with 1,000 parts, it may take a bit of time. Obviously, it's still quicker than to do it manually, but just as a consideration, I take it out because most of my assemblies are quite nice and small for demonstration purposes, but just bear in mind you might want to uncomment that. Just by the way, if ever you want to uncomment anything, you can just click on the little uncomment button or recomment button to comment things in bulk. Of course, you can just delete the little quotation or apostrophe. Okay, so then we have the document path, which is putting it in this, well, once again, navigating to this document's path. Remember, we're running this from an assembly, so that's going to be wherever your assembly that you're running it from is saved, and then pretty much a folder from that path. The folder would be DXF. So if you want all your DXFs to end up on the server, you just hard code that once again. So you could hard code the path for where you want them to be saved, and then check for the DXF folder, and if not, it will create it. So what's nice is you don't have to have a DXF folder already created. It will create this folder for you as you go along. So if you wherever your assembly is saved, it'll just create a new folder there called DXF and start populating DXFs into it, which is handy if you don't have a set template that you work with. Right, then we've got some references once again to the documents and the documents we're going to be using. A for each statement, which pretty much is going to cycle through all of our parts and assemblies. And essentially we've got some naming conventions here. So I've gone with and changed this to just be custom name, our properties value of project and part number. So it'll almost always have, you're always going to have a part number, even if it's blank, the field's there. But you could, if you were using a custom field and you didn't have a custom I property and it wasn't populated in the part, so remember that we want to be able to run this rule from any part, it will just give the name of the DXF and XXX or whatever you want. So you could say does not have name or was not information was not valid or whatever the case is. So in this case, we then have a bunch of where we're going to store it. So the folder, custom name, file name. So file name coming from here, custom name, and then the file name being, and remember that at this stage our file name is going to have the .rpt in it. So maybe something you want to look at in the future. Either way, that's what it's populating the file name with, and then it just goes and creates the flat pattern, or checks if it's a sheet metal part firstly, creates a flat pattern if it has one, and then extracts it so the S out is to the DXF format, and we've got a bunch of rules there for layers and different things that we may or may not want to come through with our DXF. You can also customize that. And then it just goes to the next part, which means cycles to the next part, next part, next part, next part, and just runs through them. So running that at this stage, we'll have a quick look in our webinar template. We probably got them, we don't have any populated, so we'll just go and save and run and see what happens. You can see it'll take anything. Once again, I know that my sheet metal parts in this case are not, well, that one flattens, it's a rolled part, but the rest of them are pretty straight and flat parts. So not a lot to actually flat pattern as such, but it's still, you know, within the sheet metal part would have a flat pattern. By the way, it also doesn't need the flat pattern to have existed beforehand. It just checks if it's a sheet metal part and creates a flat pattern, or goes to the flat pattern if there's already one available. So you don't have to worry about that beforehand as well, which can be frustrating. So there we go, running a rule like that. Once again, you can hard code the location where these flat patterns go. I've created some rules in, so you can see that we haven't done it for the flange, but in my example one that I've left for you, you'll have it there. Just in each part, I've created a rule to give it a name. So essentially all my rule does is it goes and creates, takes the I property values and names the part based on the thickness or the length or the width or whatever it is I want to see in that name, from a parameter point of view, with the ending static value of millimeter plate, so 3 mil plate or 4 mil plate or whatever it is I want. So I've given that name and added it to the part number, so that when I create my DXFs, it actually shows what I might want to see in that DXF. It could be lengths and widths and heights and whatever else you might want to see, you can add. All right, so should I ever want to have that as a universal rule? So we talk about external rules, or it used to be, I think, global rules. I don't know, I've always called them global rules, but maybe they were always external rules. Either way, we can go and create external rules that then go and are available. So the difference being is an external rule is available through any part that they're always available throughout your Inventor experience, whereas rules that we've been creating now sit only in this document. So by taking something like this rule here, and I'm just going to go and copy out my code there and making it into an external rule. I'll pop it in here. Let's go into the sample rules here and just go create new external rule, and we'll call it, sorry, my create rule. So you'll see that the difference here is when we created a rule locally, it just popped up with a what do you want to name it, and that rule sits inside. Now we're actually going out to a somewhat text format of sorts. So I'm just going to say DXFs and save it in there. Now I have the window pop up. I'll paste it and save it. Oh, I ran it again. Sorry, it's going to take time now. Like I said, this is why you should have the message, are you sure? Because if you run it, it runs. Luckily, my model's not very big, so it doesn't take very long. But if you had a couple hundred parts, you may regret clicking save and run at this point. Okay, so, no, not done yet. Not quite. A few more parts, perhaps. Okay. All right, so we're done. So we now have that DXS rule available as an external rule. I will go and open up. I don't want to open something up. I just want to create a new file just to show you quickly. If I go and create a new assembly, for example, those same external rules are available. You can map these to a network drive as well. You could put them in your Vault and map them to a Vault drive and just get the rules as long as they're that .ilogic VB. Create them through iLogic is probably the best way to go about it, but essentially it's just a text file. And I can then just run that, and it'll probably error on this one because it hasn't been saved, or not do anything because I haven't actually saved this document. But you can just right click and run it from there on any assembly you have, and boom, flat patterns. If you try this rule out and need any help customizing it, or want to learn a bit more, remember to get in contact with us. We can certainly help you with it. Okay, so last thing I wanted to discuss before we close off for this session is just drawing automation in general. We looked at the bill of materials. Now you'll see that I've got two templates that I've made for this particular model. Just one where I have the large tank and the small tank. We'll go with the large tank to look at for now. I'm in the small tank, so this is the whole catch, right? Is that dimensions and such disappear and fall off, and I'm just going to discuss that with you. So we'll go to the small tank for now because that's what I've currently got it set with. So we'll open that up, and right. So I've just created two separate drawing templates. For when I've got my tank with less parts, and one when I've got my tank extended with the extra internal parts to combine them. And the reason that I've done it that way is just because, and there's no reason you couldn't have views switch on and off or have scales change. I just thought it would be easier for this, and I then created a rule to grab the right drawing and open it up, fix all my dimensions, i.e. center them or space them, and so spacing being that if they just, as our model moves parametrically, the dimensions might fall out of sync. So if I run that, it just moves them back into place. And then we also have the ability to center dimensions. I don't know why, but this rule always needs to be run twice. I think once it does one horizontally and one vertically. I've never actually taken the time to look into it. I just run it twice. Either way, we can have drawings set up. We can have multiple templates. Now, I just wanted to talk a little bit about the automating drawings, because I suppose if anything, what we've looked at now, I've given you some rules, I've given you some good examples, and when it comes to automating drawings, I suppose that's probably the trickiest part of iLogic. So we have a bunch of tools within iLogic to automate drawings, or to help us automate drawings. We've got things like, from a drawing point of view, we've got centerline. We can talk about centerlines, leader notes. That's some of the newer stuff, in fact. Balloons, whole notes. So there's things we can do to, snippets that we can do to start referencing those things. Or, the classic folder here, we can do things like changing a view's width, or a view's height, or a view's scale. Always a handy one. So obviously, as my tank got bigger, so if I don't know, length is bigger than this, scale it to, or scale it down. If it's smaller than this, scale it up. We could have things like moving the view left, right. We've done, Man and Machine has done a few fancier rules for things like cropping views. If your view gets too long and you want to crop, just a certain section at the top, or perhaps you want to break view, you're detailing a piece of angle iron and it's 7 meters and you want to break it so that it fits within a certain area of your title block, we can also do that. Those kind of rules are a lot more complex and a lot more complicated with the coding, but it is all doable. Creating dimensions and detailing drawings is where most of your trick comes in. Spacing it, rearranging it, we could even delete dimensions. We could reattach dimensions if they become unattached. There's multiple things you can do in the drawings, but it just tends to be a little more complicated. With the snippets that you'll see here, a lot of the things that you probably want to do aren't in snippets, and the reason is that we need a bit more hard code than what switching off a feature would be, or suppressing a feature would come in. So just be warned that when it comes to the drawings, it is a bit trickier, but I suppose if you practice it and find ways to manage it, you can get there. There's also, within the recent updates, we're able to name faces, so we can attach dimensions to certain faces or certain edges with named parameters. There are options, but it does require a little bit more savvy than the general modeling. So I guess my overall message would be, use Ilogic. Don't be scared of Ilogic. It starts with, the basics. We can get from creating a simple flange and doing simple things like that to create models that are parametrically drivable within our libraries. It's always going to be handy, to just pick up a flange, know that it's got several sizes in it. I just need to change one parameter, boom, it's the right size, use it in my model. Is going to be abundantly handy. It's going to save you having to either draw flanges or draw 7 of them and pick the right one. You can go and just re-input standards. You can link it to an Excel that has all your standards in it. That sort of thing. I mean, obviously, it's probably a bad example because a lot of that stuff's in the content center already, but it could be any part that you use, perhaps little motors that come in multiple sizes that you just want to scale up as the motor needs to be a bit more powerful, or pumps, or anything really. So that's the first step, I would say. Get parametric models, get them driving, get them available for yourself. Then you can start looking at assemblies. So once you've got a couple parametric models, you could look at parametric assemblies, or I suppose assemblies with small references, or maybe functionality that you can switch on and off. This has a hole here, or that has a if it gets over a certain length, I'm going to need stiffness, so add my stiffness, or if it, things like that, that will just help you. So then you can just grab those, especially if you're in, layouts. So for example, this tank would have been used in possibly something like water treatment, whereas I could grab the tank, size my tank, drop it into my treatment plant, it's ready to go, rather than make a tank for that treatment plant and then have to detail it and all the rest later. I've already gotten to 60% before the project's even started. So bear that in mind, and good luck. If you need any help learning any of this stuff, please get into contact. I'll pass over to Simon now to close up. Simon, is that enough? I can probably go on for a little bit longer.
I know you could spend all day talking about Ilogic and rules, but obviously I'm conscious of time and didn't want to take too much of time of everyone on the call's time today. So thank you, Chris. And there's a couple of things I was really especially interested in the automatic flat patterning that you showed. I mean, that's not a standard thing. I know that's something that you have developed yourself and used yourself in a couple of examples. Obviously, it lends itself quite well to the model you were showing, but maybe there's some people on the call that are manually flat patterning everything in the model, and maybe that rule would be useful to them there.
Yeah. So certainly that will come out with the little handout that we're giving. We're happy to give that one away because it is freely available, but at least I think my snippet will show you where to put in the right text and stuff, so you guys can just fill it in for yourself. Obviously, if you need any help, give us a shout and come to us for any advice if you're unsure. But yeah, hopefully that'll help you guys out a bit, and you can use that. It'll save you lots of time creating flat patterns.
We've got a little bit of time for questions, Chris. Yes. So use the questions box if you have any new ones, but there's been a few questions that have come in while you've been presenting. So wondered if I could ask you that. The first one that came in was, how do you access Ilogic? Where do you find Ilogic?
Yeah, so it's generally we've got with the newer browsers we've got the tab here, but your general button for adding rules would be found in your Manage tab, and you've got your Ilogic panel. So you could go to bringing up your Ilogic browser used to be there. I just click the plus nowadays since the new tabs came in. So I just click on that little plus and Ilogic's always there. But you can click Ilogic browser, which will bring up your Ilogic browser. And it's right there. It's embedded in every file that you work on in Inventor. It's always there. You've got your rules, forms, global forms, and external rules. And just to create any one of them, you just generally right-click in the window, add rule. You can also add a rule with the button up there, but I normally just use my browser.
Perfect, thank you. There was another question around, obviously for this model, Ilogic works really well because you've gone from scratch, you've created the rules and it's all parametric from start. What happens if the question came in, how would you recommend starting automation on a model that already exists?
Yeah, that's okay. That's always a tricky question. It's going to depend on how you've modeled that model originally. I mean, I'm a firm believer that when we look at something for Ilogic purposes, we should be looking at it for Ilogic purposes, if that makes sense. So what I mean is that we build it for Ilogic, and the reason that and I get that obviously it's going to take you a lot of time to rebuild that model. But the reason that we're doing it with Ilogic is so that we can save time later on. So we put the time in up front. It does take longer to make an Ilogic model. Or if it didn't, we'd all do it like that every time we made a model. So we'd never have to recreate things. But it does take more time, but we put that time in up front to save us time in the long run. So it's about gauging that. Often, look, it depends on your modeling practices at the end of the day. If your model's been built well, you've used your origin planes in a manageable way, you'll probably have to break it apart and do a lot of reconstraining in the assembly purpose. There'll be a lot of work in the assembly anyway, because you'll be needing to reference things and you'd need to have clear parameters to be able to drive to. If you've used the default parameters in your actual modeling, in your parts, it's going to be very difficult to remember what D0 to D400 is in parameter naming. So we would need unique parameter naming. So it's just going to depend on what level that model is. But 9 times out of 10, I'm pretty confident it's easier and better to just restart from scratch, unfortunately.
Hopefully that answers your question, Matt. That's a good one. There was a question from Kieran, which is around for parts like angles, box sections that are used in the assembly, is it better to use the parts from the content center or to create them first as your own library?
Yeah, good question, actually. I, once again, prefer to make my own ones that are fit for purpose. The reason being is that the content center adds a lot of extra drag to the model. Not drag as such, but it adds a lot of unnecessary parameters. It makes it a little bit messier. And it also works slightly differently. It adds extra work planes. There's extra things from the content center. So I would generally remake them myself for Ilogic purposes if they're going to go into an Ilogic model. But that being said, depending on what I needed to get out of that angle, I am, because if I'm going to go take something out of the content center and just use it as a straight part, it's a 200mm angle and it's never going to be anything else, that's fine. But if I need to then set parameters to it and drive it and create, all the different buttons for it, I would definitely create it for my own purposes.
Okay, thank you, Chris. And obviously you've shown a lot, and there was a lot of, for somebody not technical like myself, it looked like it was a lot of coding sort of work, but obviously you showed how it was quite easy to take some of the snippets and to use some of the, just grabbing and picking the bits that you want. But one of the questions that came in was, how long would it take someone that's completely new to coding to get up to speed and start seeing the benefits?
Yeah, so we offer courses. I believe we have one coming soonish. I think you're going to mention that later. Don't want to spoil your surprise.
Maybe the course is the right thing. So we do offer an Ilogic training course. I mean, obviously, if you don't have the time to do this sort of stuff yourself and develop your own automation, then we can do it for you. Please talk to us. But if you're interested in getting up to speed yourself and really getting started, we have a 2-day training course that we offer, where someone like Chris will spend 2 days, probably remotely via AWS or something like this, to take you through building your own rules and really getting a good understanding of how to do it yourself on your models. Now, normally we would charge £800, but because you've sat here for 2 hours or almost 2 hours watching Chris show you some great presentations, we've got a course coming up in March that for you guys that are still watching, we're prepared to offer that to a slightly reduced cost for you. And these are the topics that are covered in that course. So for people that are wanting to get started and build their knowledge, I think that will be a great starting point. Would you agree with that, Chris?
Yeah, for sure. It's a good starting point. I do also want to just add that I know when you look at Ilogic, the coding side of it is very intimidating. I mean, we're all designers at the end of the day. I started out as a designer. I was never a coder. I would just encourage you not to get too intimidated by it, because for the most part, if you've got a good understanding of modeling practices, that's more important than the code. A lot of the code is there. You just need to know where to look for it. And you do, obviously it takes practice and time, but a lot of it's there for you, and it's pretty easy to interpret. Obviously, when you get into the more advanced stuff, it can be a little more daunting, but you'll grow with it. It's much more important to understand solid modeling practices than it is to understand the code when you're starting out with Ilogic.
Okay, that's good advice. And I believe there are a couple more questions that we'll take offline for John and for Mark, but thank you very much for your time today. I think we'll end the webinar there, but thank you for your time. Thank you, Chris, for spending the time presenting this morning. So I really appreciate everyone's time, and yeah, thank you. We'll see you again soon.
Thanks for joining us.
Take care.